Consider the data set that is made of the values 1, 2, 3, 4, and 5 as mentioned above, and assume we want to find the standard deviation. So the standard deviation equation is S equals square root of the sum of the values minus the mean quantity squared over n minus 1, where n is the number of values in the data set, x bar is the mean of the data set, and so the first thing we will have to do is find the mean, x bar, and x bar is the sum of all of the values, so 1 plus 2 plus 3 plus 4 plus 5 all over the number of values we have, so 1, 2, 3, 4, 5, n equals 5. So in this case, n equals 5. And if we add these, we find out that we get 15 over 5, which is 3. So now we know that x bar is 3, and we can find the value of s by doing the following. So the standard deviation s equals the square root, and what this value here says, this symbol means add up. Sometimes in statistics it's called the sum. So take each point in your data set, subtract it from the mean, and then square it. So 1 minus 3 quantity squared. This means add up, so plus the second symbol, 2 minus 3 quantity squared. 3 because it's the mean. Plus 3 minus 3 quantity squared, plus 4 minus 3 quantity squared, and then the last value is plus 5 minus 3 quantity squared. Oops, I wanted to erase one thing and I erased completely a different thing. And then this is all over, still underneath the square root, n minus 1, which is 5 minus 1. So we know on the bottom we're going to have a 4, because 5 minus 1 is 4. And then on top we get 1 minus 3 is a negative 2 quantity squared, plus a negative 1 quantity squared, plus 3 minus 3 is 0 squared, plus a 1 squared, and lastly we get a 2 squared. So s is going to equal square root. Negative 2 squared is 4, plus negative 1 squared is 1, plus 0 squared is 0, plus positive 1 squared is 1, plus 2 squared is 4, divided by 4. And if we add 4 plus 1 is 5, plus 1 is 6, plus 4 is 10 over 4. So the standard deviation is going to be the square root of 2.5. And if we calculate the square root of 2.5, we get a value of 1.58114 if we go to 5 decimal places, and this would be s, which is the standard deviation. So for the first lap, you're going to have to find the standard deviation for the lengths using the same procedure, and the same procedure is used to find the standard deviation of the widths.